Hello, greetings to you all once again, and I'm excited to come your way with another calculus tutorials. I can see the semester is gradually getting to an end, and I will try as much as possible to make sure that I reach my targets. Are you okay? So within this week, I'll make all the calculus tutorials, and next week I will try as much as possible to make the applied electronics tutorials. Then the next week will be more like revision for you, and I wish you the best of luck in your exam. Then at the end of it all, we are going to get our 80 plus, right? Trust me, it's going to be easy. Are you okay? So with the calculus tutorials, we are going to continue with our integration. You get it? And today we are going to talk about the integration using algebraic substitution. Then we will also talk about integration using what? Partial fraction. Are you okay? Before we dive into this area, I want you to join the Telegram page, right? It's very, very important, where you can be posting your questions, and if anyone is on the page, the person can solve it and provide you with a solution. Also, try to subscribe to my channel. It's very, very important, right? Try to subscribe to my channel so that we get more likes over here. Are you okay? Yes. So share as well. Share the video to anyone who have not seen it yet. Maybe someone is struggling with all this, and you might find it difficult, or you might not have time to teach the person. So try to share this so that the person will also benefit from it. Okay, so let's quickly move to the agenda of the day. Right. So we are going to talk about integration using algebraic substitution first. That is integration using algebraic substitution. Right. Yeah, that's what we are going to talk about for today. Substitution. Okay. Sorry. Algebraic substitution. Okay. Thank you. So let's move into this hierarchy. So assuming, let's say I have integration of what? F of x dx, right? Sometimes it is very difficult to differentiate or integrate this kind of expression hierarchy. So in order to make it simple, we always represent the f of x with u, right? We always make f of s to be u, right? So that we can substitute what? U into f of x. But you see, it is not logic to integrate, how do you call it, u with respect to what? The x, right? We always integrate u with respect to what? The u. So in that case, what do? We need to first find the u, right, with respect to the x of the function f of x. So we first differentiate the f of x, and once we differentiate it, we will make the u the subject of the relation. And how do you make the u the subject? It's more like the u is equal to what? The x, right, multiplied by the f of x. Do you get it? And now we can divide both sides by what? Both sides by the derivative of f of x. Do you get it? Yes. And after dividing both sides by 8, it cancels out. Do you get it? Then we get the x equal to what? The u over what? The outcome of the derivative. Okay. And with this, we can substitute the x, right, into the function. Do you get it? So wherever you find the x, we can substitute the u on the derivative of it. Then wherever you find the f of x, right, we can substitute what? The u. So in all, it will become something like this. Integration of what? U, right, multiplied by what? The u over what? The outcome. That's the derivative of f of x, right? And getting something like this it becomes easy to what? To simplify. So getting the expression like this becomes so easy to simplify. So that is a brief introduction of the differentiation using algebraic substitution. But before we move on to the partial fraction, I want us to solve some 2 to 3 examples. Are you okay to understand what I'm talking about over here? So let's start with example 1. Example 1, right? And the question is asking us to determine, right? Determine what? The integration of cos 3x plus 7 dx, right? So with this one, you see it's very difficult to integrate compared to what? Cos u, right? Integration of cos u du, right? This is very easy to integrate because you know that cos u is the same as what? Sin u. That is the outcome of the integration. Do you get it? So in order to make it so simple, we will first let u represent what? The 3x plus 7, right? And making u represent 3x plus 7, we can find du on what? On dx. And that will end up becoming 3, right? So with this expression, I can make du, dx the subject. So how do I make dx the subject? I first move about by doing cross multiplication. So du is equal to what? 3 dx, right? Then I can divide both sides by what? By 3. I can divide both sides by 3. And now what do I get? I'm going to get this 3 cancels the 3 here. We are going to get dx equal to what? Du on what? On 3. Very good. So now we know the value of u and we know the value of what? Dx. So we can substitute it into the original question. That is the integration of what? Cos u, because we know that 3x plus 7 is the same as u. Then the dx is the same as what? Du on what? On 3. You get it? And with this, it becomes so easy to simplify. How do you simplify this? The constant always comes out, right? And the constant is 1 over 3. So I can bring 1 on 3 out. Then I'll integrate cos what? Cos u du, right? So how do we then get this, right? The integration of cos u is the same as what? Sin u. It's going to be 1 on 3 into brackets. The result giving sin what? Sin u, right? Then we have our constant because it's indefinite integration. We always multiply it with our constant, which is plus c. Are you okay? So if you are struggling or you don't understand why we added plus c to it, first of all, it's indefinite integration, and I explained that one better in my first tutorial on the integration. So try as much as possible to watch it and you're going to be fine. Are you okay? So let's proceed. So at this point, what do I have? I'm now going to resubstitute the value of u, which was given as what? U was equal to 3x plus 7. So I'm going to resubstitute the value of u into the expression. So at the end, I'm going to get 1 on 3 sin what? Sin 3x plus 7, right? Plus c. So we can just rewrite it to make it more simplified. That is, we have sin 3x plus 7 all divided by what? 3 plus c. And that gives the final answer for the integration. Right. There's a short way of doing it. That is, let me explain how you do it in a short form, so that if it comes to objective, you don't need to what? Struggle going through all this process. So assuming I have, let's say, integration of what? Cos 3x plus 7, right, dx, right. Assuming it's an objective, what do? I focus on what is inside, right? I focus on what is inside here, right? Then I'll differentiate it. So if I should differentiate what is inside, what do I get? I'm going to get 3. So at the end, it's going to be a division. You see, with differentiation, we always multiply, but with integration, it's going to be divided by. Okay. So the result that I'll get, I'll divide it by it. Right. So what do I get here? I'm going to get 1 on what? On 3. Because the answer is what? Differentiation of 3x plus 7 is 3. So I'm going to write the result as what? As a fraction. Then what do? I now integrate the cos of all this. Right. So what's the integration for the cos of 3x plus 7? Integrating it becomes what? Sine 3x plus 7. I write them again, and I think that gives me the final answer. Then I'll just add plus c to it. So that is how it is done. So at the end, I can simplify to say sine what? Sine 3x plus 7 all divided by what? 3 plus c, which is the same as what we have up there. Let's move on to example 2 using the shortcut. Then we solve to see whether we get the same thing. So let's move to example 2. So with example 2, right, I'm asked to determine what? The integration of 2x minus what? Minus 5 exponent 7 dx, right? Before we move on straight away, let's use the shortcuts. Okay. So I have integration of what? 2x minus 5, right, 7 dx. Let's try to use the shortcut. I'll differentiate what is inside here, right? I'm going to differentiate what is inside here. So differentiating it, what do I get? I'm going to get 2. Right, so I'm going to write 1 on what? On 2. Right. Then I'll integrate the whole of it. Like I'll see this one as one expression and I'll integrate it. If I'm integrating this one, I'm going to add, let's say, plus 1 here and I divide by 8. So I'm going to write something like this. 2x minus 5, right? Then 7 plus 1, all divided by what? All divided by 8, right? Then I'll write my plus c. So what do I get here? I'm going to get 1 on 16, right? Multiply by what? 2x minus 5 exponent 8 plus c. You get it? And if I should further simplify, I'm going to rewrite it as more like 2x minus 5 exponent 8 all divided by what? 16 plus c. It sounds good, right? Okay, let's see if we are supposed to go through that process. You are going to get the same answer. Let's see what happens. So with this, I'm going to let me solve it again. Let's say integration of what? 2x minus 5 exponent 7 dx, right? I'm going to first let u equals to what? 2x minus 5. So at this point, the u on the x, right, should give me 2. So with this, I'm going to make the s the subject. I'll send this one to this side, right? So what do I get? I'm going to get the u is equal to what? 2 dx. Then later on, I'm going to divide both sides by what? Both sides by 2. Right, so dividing both sides by 2, what do I get? I'm going to get the x equal to what? The u all divided by what? 2. Very good. So now we've gotten the value for the x and we've gotten the value for u. We can now do the substitution. So now we have integration of what? U exponent 7 the u on what? On 2. Very good. So I can bring the constant out, which will end up becoming 1 on what? On 2 integration of u exponent 7 the what? The u. Now it's very simple to what? To integrate. And what do I get? I'm going to get 1 on what? On 2. Then integrating u exponent 7 gives what? U 7 plus 1 all divided by what? 7 plus 1, which is 8. Right, then I'll add my plus c. I'll add the value for u. U is giving us 2x minus 1. So at the end, what do I get? I'm going to get 1 on what? On 2 into brackets 2x minus, is it minus 1 or 5? Yeah, minus 5. 2x minus 5 all exponent 8 divided by what? 8. Then I add my plus c. So simplifying this, I think we are going to get the same thing, which is 2x minus 5 exponent 8 all divided by what? 16 plus c, which is the same as what we had when we used the shortcuts. Right, so it's always good to know how to use the shortcuts so that during the exams, when it's objective, you don't need to pass through all this long process to get your final answer. I think the process helps when it is theory, but when it's objectives, I will encourage you to always try to use what? The shortcuts. Let's move to example number 3. We'll first try the shortcuts, then we use the long process to see whether our solution is right. So example 3, the question says that we should find the integration of what? Of 4 on what? On 5x minus 3. Right, dx. Do you get it? So solution. I'm trying to use the shortcut phase. Right, with the shortcut, what do I get? This is the same as integration of what? 4 times what? Times 5x minus 3 or exponent what? Minus 1. Right, dx. Do you get it? Or even let me write it, better still, let me write it well. Let me write it well so that you understand the concept very well. So it's 4 times what? 4 times, let's say 1 on what? On 5x minus 3. Right, dx. Do you get it? You are going to use the shortcut over here. I'll first let u represent what is inside here. Right, so u is giving us 5x minus 3. Wait, I want you to see it clearly, so I'll prefer using the exponent minus 1. Let me use the exponent minus 1 so that you see it clearly. So 5x minus 3 exponent what? Minus 1. Very good. So with this one, all what I'm doing is the same thing. Do you get it? So, but as I'm teaching you, my target is to make sure that you get the better understanding. That's the reason why I'm always thinking of the best way to express it for you to understand this well. So at this point, right, I can differentiate what is inside here. Right, so differentiating what is inside here, what do I get? I'm going to get 5. Right, so I'm going to write, you see we have 4 outside. We are going to get 4 divided by what? By 5. Very good. But you know that 5x minus 3 exponent minus 1 is the same as 1 on what? 5x minus 3. Right? Yes, that's the reason why I was trying to do this, in order to make you understand that this is the same as what? Ln of the expression. Right? So integrating something like this gives you ln of what? Ln of the 5x minus 3. Do you get it? Then after, I'll just add my plus c to get the final answer. If you are struggling to understand it, please go over again. Right? This is a recording, and I'll be happy that you go over again and you understand it. If it was physical, I would have repeated myself again. But since it's recording, I would advise you to go over again, reverse the video so that you understand it very well. So simply, you are going to get 4 ln what? Ln 5x minus 3, all divided by what? Divided by 5 plus c. And that gives the final answer. That's the shortcut. Let's go through the long process. So you see that we are going to get the same thing. So assuming we are asked to integrate, that is 4 over 5x minus 3, right? That is integration of 4 on what? 5x minus 3. I hope I'm right. Yes. Right, dx. Right, so with this one, similarly, we can say that it's the same as integration of what? 4 into bracket 5x minus 3 exponent minus 1 dx. Right, so we are going to let u represent what? 5x minus 3. Right, so at this point, the u on the x, right, is equal to what? 5. That's if I should integrate du on dx. So getting this, I can make ds the subject. That is, du is equal to what? 5 dx. Now I can divide both sides by 5. Divide here by 5. Then I'm going to get dx equal to what? Du on what? On 5. So now I can substitute the value of u and dx into the integration above. So what then what do I get? It's integration of what? 4 into bracket u exponent minus 1. Right. Then dx is the same as what? Du all on what? On 5. So you can see from here, the constant term is what? 4 divided by 5. Integration of what? U minus 1 du. And like usual, u exponent minus 1 is the same as what? 1 on u, which is integrating this gives me what? Ln u. So at the end, what do I get? I'm going to get 4 on 5 ln what? Ln u plus c. That's the constant. And what is u? U is giving us 5x minus what? Minus 3. So I'm going to get 4. Let me write it well first. Ln u all divided by what? 5 plus c. So it's going to be 4 ln what? What is u is 5x minus 3. Right. So 5x minus 3 all divided by what? Divided by 5 plus c. And that is the same as what we had up there. That is 4 ln 5s minus 3 divided by 5 plus c. So the shortcut also holds. It's good to know the shortcuts, right? So that at the end, when you are solving the exam, that is when it's objective, right? You not find yourself wanting, like I said. So try as much as possible to know the shortcuts, and you always be fine. Let's move on to the next example, right? Which is quite a complicated one. We are going to use the shortcut phase, and we'll move straight away into what? Into the detail of solving it. So example 4, I guess. right? And the question is asking me to find integration of what? 3x into brackets 4x squared plus what? Plus 3 exponent 5 dx, right? So solution using the shortcuts, right? So what do you do? You see, we always integrate what's inside the brackets. Differentiate, sorry. So differentiating what's inside the bracket, what do we get? We are going to get 8x, right? That's the answer for differentiating what's inside the bracket. So you are going to divide it with what is outside the bracket over here. We are going to get 3x divided by what? Divided by 8x, right? Then we write the value again, 4x squared plus 3. Then we add plus 1 to the exponential value, that is 5 plus 1. Then we divide it by the result, which is what? 6. Do you get it? Yes, so something like this. Then we add plus c to it. So now let's simplify the expression over here. X cancels x. So we can get our x cancelling the x here, right? So since they are now cancelling, we are going to get 3 on what? On 8. Or into bracket what? 4x squared plus 3 exponent 6, all divided by 6. Then we have our plus c. But you should take note that 3 will go here 1 and 3 goes here 2. Right. So what do we have now? We are going to get 1 on what? On 16 times, because 2 times 8 times 2 is 16. Right. So let me even write it more better or more clearer. The numerator of the expression is going to be 4x squared plus 3 or exponent what? 6. And the denominator will be what? 16 plus c. So that is going to be the final expression. That's the shortcut form. Right. So let's apply the long procedure and see what we get. So the question is saying that we should integrate what? 3x into brackets 4x squared plus 3 exponent 5 dx, right? So you are going to let u equals to what? 4x squared plus 3, and the u on what? On the x should be equal to 8x, right? So we can make the x the subject over here by first applying cross multiplication. That is, du is equal to what? 8x dx. Then I'll divide both sides by what? 8x. So at the end, what do I have? I'm going to get du on what? On 8x equals to what? dx. Now that I know the value of u and I know the value of what? Of the x, I can substitute the expression into the first integration. So what do I get now? I'm going to get an integration of what? 3x into brackets u exponent 5. Then we have du on what? On 8x. So now you can clearly see that the s cancels the s here, right? And once they cancel, we are going to get 3 on 8 integration of what? U exponent 5 du, right? And integrating this u exponent 5, what do I get? We can get 3 on 8 or into brackets u 5 plus 1 or divided by 6, right? Plus c. And 3 cancels here 1, 3 cancels here 2. So at the long run, I'm going to get u exponent 6 all divided by what? 16 plus c. And what is u? U is giving us what? 4x plus 3. So at the end, what do I get? I'm going to get 4x plus 3 all exponent what? 6 divided by 16 plus c, which is the same as the shortcut on, right? The shortcut method. So it's always good to know the shortcuts. Once you know the shortcut, it's easy to what? To move on, right? Let me solve the last one using the shortcuts, right? Maybe I might continue with the long procedure sake of the time, right? So let me solve that one with the shortcuts, and if I still have time, I'll move on to the long procedure. So the question is saying that I should evaluate, right? Evaluate the integration of 0, we have 1 here, and we have 2e 6x minus 1, right? Then we have dx. So if I should integrate it, right, it is definite integration. So I need to know the values too. So integrating this, right, let me put all into brackets first. It's not going to be easy, but we are going to do it. So we have, if I should integrate what's up here, I'm going to get 6. Yes, I'm going to get 6. So first of all, I have 2 as a constant over there. Now divided by what? By the 6 that I had, right? And I'll just repeat myself, which is e 6x minus 1. Because we know that integration of EA is the same as what? EA, right? And this time, we are not going to introduce the constant because it's definite integration. If you are struggling to understand that one, please watch my previous video. So at the end, I'm going to have 0 and 1 here, right? Which is very, very simple. So what do we have? You are going to get these 2 will go into itself 1. This goes here 3. I'm going to get e 6x minus 1 all divided by 3, and that is 0, 1. And because it's definite integration, what do I get? I'm going to get e 6 to bracket 1 minus 1 all divided by what? By 3 for the first term, and the second one will be minus e 6 to bracket 0 minus what? 1 all divided by 3 again, right? And if I simplify, I'm going to get e 5 divided by 3 minus e, how do you call it, minus 1 divided by 3, and that one should give me, I think, 40, how do you call it, 49.35. That's if it's a simplify. I'm going to get 49.35 as the final answer. So that's the shortcut. Let's move on to the long method and see. That's if you are given the theory, right? So we have integration of what? Integration of, how do you call it? 3x into brackets 4x squared plus 3. No, that's not the question. Sorry. So we have integration of what? Of 1 0 over here. Then we have 2e 6x minus 1 dx. Yes. So with something like this, right, what do? I'll let u represent what? 6x minus 1. So with this case, I'll say that du on dx, right, equals to what? 6. Very good. So what do? I make dx the subject over here. So du is equal to what? 6 dx first. Then I'll divide both sides by what? By 6. So at the end, I'm going to get dx equal to what? Du on what? On 6 as the final answer for the dx. So now I will just substitute. So integration of what? 0, 1, 2, e, u, right? Then I have du on what? On 6, right? I know that this can cancel. 2 go to itself 1, 2 goes here, how many times? 3. I'm going to get 1 over 3 out, right? The constant 1 over 3 will come out. So I have 1 on 3, definite integration of what? 0, 1. Then we have eu du. By integration of eu is the same as what? Eu, right? So at the end, I'm going to get 1 on 3. Then I have eu, right? Then 0, 1. You get it? So what do I have now? What is u? U was given as 6x minus 1, right? That's the value for u. So I just substitute the value there, which will be 1 on what? On 3 e 6x minus 1, right? Then we have 0, 1. So what do I do now? I'm going to just substitute the values, and I'm going to get 1 on 3, right? I have e. If I substitute 1 first, I'm going to get 6 into bracket 1 minus 1, right? Minus e 6 into bracket 0 minus 1, something like this. So what do I have? I'm going to get 1 on what? On 3 e 5 minus e what? Minus 1, which is the same as what we had there. If I should distribute the 1 on 3, I'm going to get e5 on 3 minus e minus 1 on 3, right? And this should give me the 49.35. Yes, so you see the shortcuts and also the long process is the same, but it's always good to know the shortcuts. Once you know the shortcuts, you are going to get, how do you call it, the shortest way to solve multiple choice questions. So try as much as possible to do that. We are going for a short break. When I come, I'll continue with what? With the partial differentiation. So partial integration using what? Partial fraction, right? Yes. Did I use, how do you call it, partial integration? Let me visit it to see whether I use partial integration. Partial fraction, very good. I use the same thing. So I'm going for the break, and I'll come back later on. Best regards. All right, welcome back. And this time we are going to continue with what? With partial fraction integration, right? Or integration with partial fraction. Integration with what? Partial fraction. Yes. So with this, I'm expecting you to know your partial fraction very well. But if you've forgotten, right, as a science student, let me just move on to recap what is under partial fraction. Right? We have different types. We have 3 types, 3 main types, right? So with a type 1, they are all found in your Acula. So if you have your Acula, you can visit them and you understand it very well. So with the type 1, assuming I'm having what? An expression, let's say bx, right, plus q, all divided by, right, x minus a. Then we have x minus b, right? And I'm asked to find the partial fraction of this. This is also termed as non repeated linear factors, right? Because these two are linear factors, right? The x is exponent 1, so they are linear factors, but they are non-repeating. So I can term it as non-repeated, right? Linear factors or factor. Do you get it? So with this one, if I want to split it, then the rule is that I'm going to write a on what? On x minus a, right? For the first one, plus b on what? On x minus b. That is an identity of what is at the left hand side. Yeah. And we also have type 2. This is just a recap, right? So, and since we have non-repeated linear factors, we also have like repeated, right, linear factors, right? So with that one, assuming I have, how do you go it? I'm going to say I have b into bracket x plus what? Plus q, all divided by what? X minus a. That is, I have another x minus a. So it's a repeated linear factor. Or this is also the same as if I have, let's say, bx plus q, right? All divided by what? X minus a squared. You get it? So if I have this expression, then it's identical to, let me write it again, x minus a all squared. It's an identity of what? A on what? X minus a, right? Plus b on what? X minus a squared. Yes, this is also the type 2, right? And I'm going to end at type 3. We have a lot, so I'm going to also talk about type 3. And that one is when we have a non-repeated quadratic factor, right? So a non-repeated quadratic factor. Right. So with this one, let's assume I have something like, let's say bx squared plus qx, right, plus r. And the denominator is a non-repeated quadratic factor, which is more like s squared plus bx plus c. Then the partial fraction of it is going to be more like ax plus what? Plus b, all divided by what? X squared plus bx plus c. So these are the 3 types that we are going to talk about. But with our questions, right? Before I start solving questions under this for integration, I need to teach you the trick, or let's say the integration using the trick form. Okay, if I don't teach you integration using the trick form, and I go ahead to solve questions under the type 3, you are really going to struggle. So all the questions that I'm going to solve will be under what? The type 2 and the type 1. But tomorrow, God willing, when I finish teaching you the, how do you call it, integration using trig, I will try as much as possible to factor in the type 3 of the partial fraction. Alright, so let's begin with, let's say, examples. So I'm going to solve example 1, right? And with example 1, I'm asked to what? Find the integration of 2x plus 3 all on what? X minus 2 all squared, right? With respect to what? X, that's dx. So with this, I first need to bring out the expression. That is 2x plus, let me write the solution. right? I first need to bring out the expression 2x plus 3 all divided by what? X minus 2 all squared, right? And this is identical to what? That is, it's more like the type 2, right? Which is more like the repeated linear factor. So we have a repeated linear factor at this point. So we can say that 2x plus 3 all divided by x minus 2 all squared is identical to what? To a on what? On x minus 2, right? Plus b on what? On x minus 2 all squared, right? So what's the LCM over here? The LCM for these two is, how do you call it? X minus 2 all squared. That is, if I should simplify what's at the left hand side, the LCM is x minus 2 all squared. X minus 2 will go into x minus 2 all squared how many times? X minus 2. So I'm going to multiply a with the factor which we had, x minus 2. Right. This is the simple algebra that we all learned in basic school. For instance, if I have 5 divided by 3, then I have plus 2 divided by 6. The LCM here is going to be what? 6. 3 can go into 6 how many times? 2. So the numerator, which is 5 divided by what? The 2 plus 6 will go into itself 1. So we have 2 into brackets 1, right? The numerator is 2, then multiply by the factor which is 1. The same applies to this. X minus 2 goes into x minus 2 squared 1. So 1 goes into it, x minus 2, right? So the x minus 2 multiplied by the a. That's what we had for the first term. Then plus x minus 2 squared will go into itself 1 time. So we have b multiplied by what? 1. Which obviously we don't write the 1. Are you okay? So let's proceed. So at this point, I can simplify the numerator, which I'm going to get ax minus 2a, right, plus b all on what? On x minus 2 all squared, right? And at this end, we have 2x plus 3 all divided by what? X minus 2 squared, right? So since they are identical, right, I can compare the numerator. So we have 2x plus 3 is equal to what? Ax minus 2x plus b. Let me rewrite this one so that it will become clear to you. This is the same as 2x plus 3 is equal to what? Ax plus into brackets. That is 2a. Sorry, I should have written a here. Very good. So it is ax minus 2a plus b, right? So at this point, if I should group them, I'm going to get ax plus what? 2a plus b. Very good. So looking at this, it's very clear to compare. I can compare the coefficient of x over here with the a here, right? Then also I can compare the plus, how do you call it? The constant here with the whole of the constants at this point, right? So it's now easy to simplify. I'll get 2 is equal to a. That's the first equation, equation 1. If I should compare the green side, I'm going to get 2 is equal to a. That's the coefficients of x. Then also with the constant side, I'm going to get 3 is equal to what? Minus 2a, right, plus b. Okay, very good. So with this, what do we have? Right, I can just substitute the value of a and what? And how do you call it? Into equation 2. Right. So simplifying b over here from 2. I will say that b is equal to what? I'm going to send a to this side of the equation. So I'm going to get 3 plus what? Plus 2a. Are you okay? So I know that a is equal to 2 from equation 1. So I'm going to get b equal to what? 3 plus 2 into bracket 2. And that should end up with what? 3 plus 4, which is equal to what? 7. Right. So we have a equals to 2 and b equals to what? 7. So at this point, we can substitute it into the main identity, which was this. Right. Let me call it identity. Let's see. Small. Let me call it alpha. Right. So I can substitute it into the identity over there. And what do I get? It means that 2x plus 3 on what? On x minus 2 all squared is identical to what? To 2 on what? X minus 2 plus, that is b was 7. 7 on what? X minus 2 all squared. Right. So in this case, I will say that the integration of 2x plus 3 all on what? On x minus 2 squared, right, dx is equal to what? Integration of the product of 2 on what? X minus 2 plus 7 on what? X minus 2 all squared dx. Right. I can apply distribution of the integration for all of them. Right. So in this case, what do I get? I'm going to get integration of what? 2 on what? On x minus 2, that is dx, plus another integration of what? 7 on what? X minus 2 squared, right, dx. Very good. Very good. So at this point, it's very easy to what? It's very easy to simplify. Do you get it? We are going to apply our shortcuts that we learned before the break. We are going to apply the shortcuts here. Right? So you should take note of it. The reason why I was able to distribute it is because if I have integration of a plus b, right, dx is the same as integration of a dx plus integration of b dx. So if you are wondering why I was able to get this, it's more like this rule holds, right? So I was able to distribute it nicely. Now that I've been able to distribute it nicely, what I need to do is to what? Simplify this. We are going to use our shortcuts, right? Let me write it clearly so that it will be easy to use the shortcuts. This is the same as integration of what? 2 into bracket x minus 2 exponent minus 1 dx, right? Plus integration of 7 into bracket x minus 2 minus squared dx. Now let's apply. We are ready to go. So I'll differentiate what is inside. And when I differentiate it, I'm going to get 1. So it's going to be 2 divided by 1. That is, after differentiating what is inside here, I had 1. That's the reason why I divided by 1 here. Then, when this exponent minus 1 is the same as what? Ln. So I'm going to get ln into bracket x minus what? Minus 2. Right? Yes. So, we are done with the first one. Then plus the second one. What's inside here? If I should differentiate, I'm going to equally get 1. Right? I'm going to get 7 divided by 1. And this time, it's not going to be ln, because it's minus 2. We are going to get x minus 2 plus what? Plus 1. All divided by the result is going to give us minus 1. Right? Then we have our plus c. Do you get it? Yes. So at this point, what do we have? We can simplify what we've written over here. We have 2 ln what? X minus 2, right? Plus, or let's say this is a minus here. So it will come and overcome the plus here. So let's move on straight away to say that x minus, right, minus 7 into bracket what? X minus 2 exponent what? Minus 1, right, plus c. We can further simplify this, and this one is going to give us 2 then what? X minus 2 minus 7 all divided by what? X minus 2, right, plus c. And this gives the final answer. Are you okay? Yes, this is the final answer for our integration. So once you are done with the partial fraction, you just proceed, then you move on. Let's solve the next question. We are going to solve about 3 questions. Then we'll call it a day. So example what? Example 2, right? So he said I should determine the integration of what? Integration of 5, let's say x squared minus 2x minus 19 all on what? All on x plus 3. Then we have x minus 1 squared. So this is made up of a linear factor, a non-repeating linear factor, and also a repeated linear factor. So we have all of them combined. The solution, we pick our, with respect to the x, right? So we pick our variable out, or our function out, which is 5x squared minus 2x minus 19 all on what? On x plus 3. Then we have x minus 1 squared. And this is an identity of a over what? The non-repeating linear factor, right, plus a repeating linear factor. So we are going to get b divided by what? Divided by x minus 1, then plus c over x minus 1 squared, right? So this is more like the type 1 and type 2 combined, right? So it's an identical of what? You look for the LCM. The LCM is simply going to be x plus 3, and we'll have x minus 1 squared. So a multiplied by the common factor, and yours with the common factor, it's just going to be s minus 1 squared, right? So we're going to get x minus 1 squared. We get it. Then we have plus, then we have the b multiplied by the common factor. The common factor is going to be x plus 3. Then we have x minus 1. That's going to be the common factor for the b part. And the c is plus c multiplied by the common factor. The common factor is going to be just x plus 3. Very good. So with this, we can simplify what's over there. There is an identity of, let's say, I have a, right? If I should simplify this x minus 1 squared using the binomial expression, I'm going to get s squared minus what? 2x, right, plus 1. That's it. We know that a plus b, or a minus b, sorry, let me use the a minus b. A minus b all squared is equal to what? A squared minus 2ab plus b squared. So that was what I used in getting this. Do you get it? Yes. So you should take note of it. You are a scientist, and as a scientist, you need to know the shortcuts in doing things. Are you okay? Yes. And let's simplify the b part. B, you are going to get x times x, which is x squared. Then x times minus 1, you are going to get minus what? Minus x, right? Then we have plus 3x, right? Then we have minus 3. as if I should expand this 2, right? But we clearly know that if I simplify this to, I'm going to get what? 2x. So you should take note of it. I'm going to use it very soon. So at the end, let's continue. And with this, I can also expand the c part, which will give me what? Cx plus what? 3c. Then all divided by the denominator, which is x plus 3. Now I have what? X minus 1 squared. Right, very good. So now I can expand what I have. So it's an identity of what? Of ax squared minus 2ax, right, plus a, very good, plus bx squared. Then this will be plus what? Plus 2bx, right? Because I showed you that this 2 is 2x. So I just multiply it with a b. I'm going to get 2bx minus what? 3b, right? Then plus cx plus 3c. All divided by the common denominator, which is x plus 3. Then x minus 1 what? Squared. So with this, right, I can group terms. Or even let me just compare straight away before grouping the terms. Else it's going to be so complicated and all those stuff. So with this side, right, let me repeat this whole thing again. Let me repeat this expression over here. So I have 5x, right, is it x squared? Yeah, 5x squared, right, minus 2x minus 19, right, 5x squared minus 2x minus 19, all divided by, which is the same as what? X plus 3, then I have x minus 1 squared. So with this, I will say that the numerators are equal. So I just equate the numerators. Like 5x squared minus 2x minus 19 is equal to what? Ax squared minus 2ax plus a plus bx squared plus 2bx minus 3b plus cx plus 3c. Very good. So let me group the terms very well. Where there's a square, I'll bring them at one side, and where there is b squared, I'll bring it at the other side. So you can see that we have a squared here, we have bs squared here. I think those are the squares that we have, right? So let me write them again. I have as squared, right, plus bx squared. Now we are moving on to the x parts. So I have minus 2ax here, and I have plus 2bx, then I have cx. So let me write them. Minus 2ax, right, plus 2bx. Do you get it? Yes. Plus cx. Now let's group the constants, which I'm going to use an orange ink. Very good. So I have plus ax here, and I have minus 3b, and I have plus 3c. So plus a, right, minus 3b, then plus 3c. So you can see that they are clearly written, and I can now factorize them. Let me factorize them. So I have, let me use this ink to write the equal to, try to be a little clearer. Are you okay? So with this, I have a plus b, right, and that gives the s squared. I factorize s squared out. Then I also have plus plus, then I can factorize the x out. That is minus 2a plus what? 2b plus c x. Okay. Then the last one, that is plus, that's the orange one, which is the constant. I have a minus 3b plus what? 3c. Right? Yes. So this is also identical to what? We have 5s squared. Then we have the green side, which is more like the minus 2x, right? Then the orange side, which is minus 90. So you see, I can compare the coefficients of each term. I can compare the first one, which is, I'm going to get, how do you call it? 5 is equal to, we have just a plus b. And that is equation what? Equation 1. Then I have minus 2 is equal to what? Minus 2a plus 2b plus c. And that gives what? Equation 2. Then I have, how do you call it? Orange one, which gives minus 19 equals to what? A minus 3b plus 3c. That is equation what? 3. So with this one, I don't need to worry myself solving this one again. I can just rewrite them very well and use the calculator. So if I'm using the calculator, I need to rewrite them very well. That is, I need to introduce plus 0c here. Okay, so that's all the variables will show. So I have a plus b plus 0c is equal to 5. That was equation 1. And I also have minus 2a plus 2b plus c is equal to minus 2. And that will be equation 2. Then I have, how do you call it? A minus 3b plus 3c is equal to minus 19. And that is equation 3. So at this point, we can use our calculator to solve it nicely. And if you use the calculator to solve it, you are going to get a to be what? A to be 2, b will be equal to what? 3, and c is equal to what? Minus 4. So we just substitute it into what? Into the first expression over here. Right. So we can see, or we can clearly make a deduction that 5x squared minus 2x minus 19 on what? On x plus 3x minus 1 squared is identical to what? It's identical to, how do you call it? What's a here? You have 2 on what? X plus 3, then plus b on, what is b? B is equal to 3, sorry. So we have 3 on what? On x minus 1, right? Then c is negative, so here it's going to be negative. Minus 4 on what? X minus 1 all squared, right? So at this point, integration of 5x squared minus 2x minus 19 all divided by what? X plus 3 x minus 1 squared is the same as what? Integration of the x. Sorry, I always forget the dx. So the x, right, is the same as what? Integration of what? That is 2 on x plus 3 plus 3 on what? X minus 1 minus 4 on what? X minus 1 squared dx. Right. So at this point, It's very easy to what? To simplify now. So we simplifying. We are going to get integration of what? 2 on what? On x plus 3 dx over here plus integration of what? 2 on what? X minus 1. Then we have under dx. Right. Not 2, 3. Praying I don't make mistake on the way. Yes. Then minus integration of what? 4 on what? X minus 1 squared under dx. Right. This one can be further simplified. So we have integration of what? 2x plus 3 minus 1. Right. Dx. Then I have plus integration of what? 3 into bracket x minus 1 dx, right, minus integration of 4 into bracket x minus 1 minus 2 dx, right. So at this point, what do we have? Now I can use the shortcut form as we discussed last, right. So differentiating what is inside, I'm going to get 1. So it's going to be 2 divided by 1. Then if it is minus 1, it's simply going to be ln of what? X plus 3. Right? Ln of what is inside. I'm done with the first one. Then plus this one, if I should differentiate what's inside, I'm going to get 1. It's going to be 3 divided by 1. I'm going to get ln of what? X minus 1. Very good. Then this one, we are going to get minus. So differentiating, I'm going to get 1. So 4 divided by 1. Right. Then this is not going to be ln because it's exponent minus 2. So I'm going to get into brackets x minus 1 minus 2 plus 1. Then the results is going to give me minus 1. So I divide it with the results. Right. Yes. Then I'm going to write my plus c. I think I'm done. So let's continue. So at this point, I'm going to get what? 2 ln x plus 3 for the first one plus 3 ln what? Ln x minus 1 for the second one. Then we have negative here, so I'm going to get plus. So plus 4 what? 4 into bracket x minus 1 exponent minus 1 plus c. Right, this can be simplified. We have 2 lanes here, so you can simplify it. So how do you call it? I'm going to get loss of indices. Please don't forget x plus 3 exponent what? 2. That is the loss of indices. We say we can drag it up there. Then I have plus again plus ln of what? X minus 1 exponent what? Exponent 3. Right. Then the next one, what do we get? I'm going to get plus 4 on what? On x minus 1. Right. Plus c. Very good. But we know that if they are summing up, right, I can just multiply. Right. So multiplying it, I'm going to get ln into brackets x plus 3 all squared multiplied by what? X minus 1 all cubed, right, plus 4 on what? X minus 1 plus c. But if it is theory, if you are solving it, you can leave it here. Okay, let's leave it here and we are good to go. Right, when you are done with this, you are done with the integration, so you can leave it here. We don't want to stress ourselves. So the integration ends here. Right, I'm just simplifying so that you see it clearly. Okay, so we are going to end here. I wish you the best of luck. Best of luck. Okay, yes, I wish you the best of luck. Just keep on learning. I'm going to send more questions. Keep on learning, and we are going to get there. By tomorrow, I'll try to make the next video, and by the close of this week, I'll be done with the calculus tutorial so that you get time to prepare very well. I wish you the best of luck once again. Please join the Telegram page, and we will all be fine. Okay, all the best. Bye bye.